the limit superior and then the limit inferior. But you'll find that limit superior, sometimes instead of writing all this, what we do, we write a brief thing or something small, which is limit. This is a soup of a sequence xn. Then as n goes to infinity. Sometimes instead of writing still this, we write it as limit. Then we write this line at the top that implies soup. Then instead of writing now soup here, we write x n. Then we say n goes to infinity. So from there, what we do, then also instead of writing this, sometimes we just write like this, limit as n goes to infinity of soup of just x. Then we keep this, meaning that we pick the elements, and this is the value, meaning that we can have a set of elements. We can have a sequence xn. We separate this sequence into subsequences xnk1, xnk2. Then when we separate it into two, from this one, which is the upper, we can get the soup. From this one, which is the smaller, we get the infimum. And in this case, it is simple to see that what we call the limit soup. Let me see from here. Yes, the limit soup, therefore, we get it by donating it to BK, and our BK therefore will be the same as the soup. Soup is the same as the biggest or the maximum of this is the set xnk, such that n is greater or equal to k. Remember, this is the ek. Then what we do, if this is the set, having maybe 1, maybe 4, maybe 6, maybe 6.8, maybe 6.9, you see that it converges will be close to 7, meaning that we shall come and then pick up this value where it is converging. Then also, we are going to see that, please, it is page 35. We are going to see that this lower subsequence, we are going to call it AK, and this is the infimum. The other infimum, this is soup, the other supremum we saw. This is the inferior, this is the inf. Of the set xn, but n must be greater or equal to k. So, now, you see that this is the sequence I'm talking about. I can give you something funny, something like an example. If you're having a sequence xn is equal to -1 to the power n, you see that this one here, when you try to expand, we are going to get -1, 1, -1, 1, -1, 1, and others. Now, when you look at this properly, you can have subsequences, subsequence nk1, and you call it what? And you call this one 1, 1, 1, and others. You can also have another subsequence nk2, and you have -1, -1, -1, and others. You see that from here, from this subsequence, our infimum of this, meaning that it will be AK, it will be AK. Then from this sequence here, which is this, our supremum will be B. So that is the interpretation. And from here, since already we have seen We have BK in our pocket and we have AK in our pocket. From here, we have seen that the BK is the biggest, and you have seen AK is the smallest, meaning that in this case, it is general that AK is less or equal to BK. Because we have seen this one is defined by the sup, this one is defined by the infimum. We are going to see some examples that can help us understand much this. So, when you look at the proposition 3.3, 3.38, this is page 36. Page 36. That is the proposition. Can you try to look at it properly? It will tell us that AK is ever less or equal to AK plus 1, and the same way BK plus 1 is less or equal to, this is BK. What are we for every K? What are we saying is that since we have already taken BK to be our sup, and also have taken AK to be our inf, meaning that this is the smallest possible and this is the biggest possible, meaning that any other element should be within that. That's why we are saying AK is smaller than any other value in K, in A. And also we are saying BK plus 1 is smaller than any other value compared to B. When you look at this critically, when you look at this practically, we can say, if you're having a sequence n, which is of the nature 1 over n, if we are having a sequence like this, you will see that we are having 1, we are having 1 over 2, you are having 1 over 3, you are having 1 over 4, and others. And when you try to check this thing properly, you will see that the biggest, as n goes to, the smallest as n goes to infinity. As n goes to infinity, it will be 0. That's where we proved from the previous work that we are having here is 0. That's where from the other work we proved that this is a 0, and this sequence will come and camouflage within there. Meaning that as n goes to positive infinity, our AK will be 0. Meaning that this sequence will keep reducing. You find a point where you have 1 over 1,000, 1 over 1 million, 1 over 2 millions. You find all in these situations that it will be close to 0, but it will not be 0. Meaning that the infimum, the smallest within this set, is 0. So that is the interpretation there. And then we don't go much into that. We are going to illustrate that with examples. And then the proof, that is the reading assignment. That is the reading exercise. You are going to help me read through and then you try to understand. Where maybe you may not understand, you ask a question there. So I want you to look at definition. Definition is 3.39. And then we are saying let xn be a sequence in R. And remember we said a sequence in R, it implies that the elements or the terms of xn are in R. Say xn, it will be like if it is equal to 1 over n, this one will equal to, this is 1, this is 1 over 2, this is 1 over 3, this is 1 over 4, and the others. You see that 1, we have a half, we have a third, we have a quarter, all are elements of R. That is the interpretation, meaning that terms within they are real numbers. That is the interpretation. This is a real number, this is the real number, this is the real number, this is the real number, and all others will be real numbers. That's what we are saying by a sequence to be in R. Then we are defining, we have said a sequence xn is in R. Then what we are saying is that the limit superior of xn, the limit superior of xn denoted by a limit. I think you can see we have already written those things. Limit sup xn, or limit as n goes to infinity of sup of that, or limit that. But the definition is the limit as n goes to infinity of this is the sup of xn, this is the limit superior, equals to this is the limit as n goes to infinity of bk, and then this one here equals to the limit, to the infimum of the sup. This is k coming from n, of the sup of the set xn. This is n greater or equal to k. So we are going to mainly use this because this is the one I've explained to you. We have already defined what B is. B is the sup of the given sequence. Then what we are saying is that this expression here, we are going to take its limit as n goes to infinity. It will be our limit sup. And then this one here, I'll tell you when to use it, this expression here. We are going to see how we use it. And please, I'm giving you just 1 minute to read through limit inf, limit inferior. You read through it. But what I should tell you is that limit inferior, now instead of superior, we shall go with limit inferior as n goes to infinity. Of this is in xn, it will equal to the limit as n goes to infinity. Of this is ak, the difference is simple now. Here we take a bk, here we take ak, meaning that we identify the limit of ak, the smallest subsequence, and here we take the biggest as n goes to infinity of bk. So that is the difference. And then I'm going to this. So they are outside our handout. So we are going to say properties or relationships. We can say relationships between limit sup and limit inferior. The relationship is between limit inferior and the limit superior. So in this case, now we can look at two things here. That limit sup, yes, the first one is limit as n goes to infinity of inf xn. This is the limit inferior, is less or equal to limit as n goes to infinity of this is the sup of xn, meaning that ever limit inferior is either less or equal to the limit superior. Sometimes they are equal, other times they are not equal. And the two, limit inferior as n goes to infinity of xn is equals to limit superior as n goes to infinity of the same sequence xn if and only if, meaning that the moment I say if and only if, just know it is double-sided now. If and only if limit, this is n goes to infinity of the sequence exists And remember, we said if the limit exists, then it implies that there is convergence. Otherwise, this is convergence. Meaning that if these two, if you find that these two exists, limit sup exists, limit superior exists, automatically these two must exist. Then if you find that they are equal, then you just know this limit here, the limit of the same sequence converges to that same answer you have got. That is the interpretation there. Then I think we can, other things which I may not talk about now, because you must be knowing about this, what you should know, what you should be able to know or to remember from this work is this smaller table here. I want to show you the sum relationship, that if I have a number n coming from n and is even, then n plus 1 also which is coming from n must be odd. This one is going to look as if it is challenging you, but it should not. N coming from n, if it is even, then n plus 1 is odd. If we are having maybe n is equal to 2, then you see that n plus 1, which is 2 plus 1, will equal to 3. This is odd. You can pick any. Even if you pick 100 plus 1, you'll be having 101. That is already odd. So also you can see, please look at this expression clearly. Should not get confused. Also in the same way, if n coming from n is odd, if it is odd, then n plus 1 coming from n must be even. Please look here, it should not confuse you. You see this is n, which is odd. Like if I can take an example, I can take my n is equal to 3. This 3 is odd. Then when I take 3 plus 1, I will get a 4. This one here is even, but this was odd. Please, you should not confuse that too. You should not confuse that too. Here, when you start with even, you end with odd. When you start with the odd, you end with even. Please, I'm requesting. Any confusion here? Any confusion there? Can you type if you have a confusion? Okay, let's move on. You good? That is nice. Now, hope you have written it down. Now, another thing there, maybe something which we may need later, is that generally in math, when I write 2n, this implies an even number. When I write 2n. When I write 2n plus 1, this implies an odd number. So you should be knowing also that. You should also know, because we are going to introduce series after some little time, because we know we are having sum to infinity. Sum to infinity, we are having of a GP and of AP. For a GP, we know that our sum to infinity will ever equal to what? Is it a over 1 minus r? For r, this is less than or equal to less than 1. And For this is for AP. This is the sum to infinity will equal to this is n over 2 into 2n plus this is n minus 1 over d. And probably you should remember here that if our n for r greater than 1, we should ever take sum to infinity s infinity as a over r minus 1. So you should be knowing this. You should be able to remember such. I know you covered, but you should be able to remember. So someone has sent a message that we didn't cover subsequences. Coordinator, did we cover subsequences?
No.
Let me have a look at here. Coordinator, did you do exercise number 5? Hajat, did I give you exercise number 5? Exercise 3.37 number 5? Did we do exercise 3.37 number 5? Did I give it to you on page 35? Someone to answer me, please.
No, you give us number 4.
Did you do it, please? I want the answer to, and then we continue.
No, we didn't.
You gave number 4, the upper one. Sandwich only.
Okay, we are going to create some time, we go back there. We're going to create some time, we go back there. Because even if we don't know, we can try to explain much so that we can try to link up that. We shall come back and we do it. We shall discuss, because this is under recording and I wouldn't like to spoil your recording. Let's just move on with it. We are going to come back and cover it again. Now, you see, let's go to theorem. Let's look at some examples there, because other theorems already are covered. Examples. You find limit sup, limit superior, and the limit inferior in each of the following. In each of the following, I think let's do some 4 or 5 numbers, then we leave it there today. We're going to have number 1, xn equals to, this is n, 1 over n, n is even, this is n is odd. 2, xn equals to -1 to power n. 3, xn equals to 1 plus -1 to power n. 4, xn equals to n into 1 plus -1 power n, then 5, xn equals to 1 plus -1 to power n of 1 over n. And then let's try to look let's follow the order, I think, to be able to catch up with the. Please, these are the examples we are going to look what. You'll be able to follow, then you do that work. So let's try and look at number 1 at a time. So number 1, let's try to see what happens. We are having, this is xn equals, this is n is even, this is 1 over n is odd. Then now look here, by just sampling this statement here, you will see that you'll see something funny here. When you substitute even odd numbers here, remember odd numbers, when they say n is odd, they are telling you to use 1, to use a 3, to use a 5, to use a, is it 7 and the others? And when they say even, they are telling you 2, they are telling you 4, they are telling you 6 and others. So the trick is, from these 2 sets, you should pick A and you should pick BK. But we have said BK must go with the function that passes at the top, or the bigger one. When they say AK, they should look at the subsequence which is passing below. Subsequence, I'm referring to a sequence which is acting like the normal sequence, the other original sequence. But it is as a result of picking some.
Excuse me, sir.
Some element from the sequence. Now,
Excuse me, sir.
Karugaba?
You are moving.
Karugaba?
The camera to sing it very well.
Okay. Okay. So you see, you see this expression here. This lower part is going to produce values which are smaller compared to this. So we are going to say let. If this one is going to produce values which are smaller, then it's going to produce A. If this one is going to produce values which are bigger, because when we are substituting this, we are going to have a 4, so the 2, a 4, a 6, 8. When I go on substituting even, when I go on substituting odd here, I'll get 1, I'll get a third, I'll get 1 over 5. You see that these ones, they're already small compared to this. So I'm going to pick A to be this. Let my AK equals to, this is, and we say the AK is the infimum of this is the K greater or equal to N. Or let's see, I can use the other one around. Let me see this. Okay, we can use it, it's okay. Of this is in we can say of this is XK, and then this one equals to infimum of this is k greater or equal to n, of this is the sequence now we are picking is 1 over k, or 1 over x, or 1 over n. Now, look here, when I put here k, it implies that I've changed this part. Instead of n, I'm going to be moving with k. But if it is confusing you, you are free to maintain your a 1 over n. And then you here you say xn. You are free to use it. This one equals to what? This is when I try to check, we are supposed to look for the infimum of k greater or equal to n. Of this is 1. This is a third. This is a quarter. This is 1 over 5 and others. Then finally here, remember we are saying as n goes to positive infinity, meaning that we are going to go on substituting up to infinity. You'll find that this thing will come back to 0. Because remember, this is 1 over 3, you reach 1 over 100, 1 over 2 millions, 1 over, so long as it is 1 over something, we are going to reach a point when you are having 0.000000 maybe 1. Meaning that when you try to look at that, it's going to go to 0. Now, this implies that limit as n goes to infinity of the inferior of xn will equal to the limit as n goes to infinity of 0. Because this is our ak. Then finally here we are going to get a 0. So what are we doing? We have taken this one to be our ak. We have seen what ak will bring. We have bring a 0. Then we have taken its limit as n goes to infinity. We end up with a 0. That is the limit inferior. Then, the limit superior. Limit also let bk be equal to this is the sup as n greater or equal to n of this is xn, and this is the same as sup of k greater or equal to n of this is n. Because remember, here we have picked this to give us a, so this one is what we pick to give us b. And in this case, when you look at the way it is going to appear here, n greater or equal to n, and we are going to have here 2. We are remember we are using even numbers. We are having 4. We are having 8. Actually 6 here. 8 and others. This is 2, 4, 6, 8 and others. Meaning that this expression here will keep continuing and it will only stop at infinity. Because remember, when you put n is equal to 20, it will give you 20. When you put n is equal to 1 million, it will give you 1 million. Meaning that where we need to converge, it will converge at infinity. So, therefore, our bk will equal to positive infinity. So, limit as n goes to infinity of this is sup of xn will equal to limit as n goes to infinity of infinity. Remember, this is the same as just saying bk. And then this is limit as n goes to infinity of this is positive infinity. Because our bk here is equal to positive infinity, and then finally you're going to have the answer positive infinity. Therefore, we have seen limit sup, limit superior equals to positive infinity. Limit inferior will equal to 0. That's how we answer the first number, or the first part. Then let's try to look at number 2. For number 2, we're having xn equals to negative 1 to power n. And when I look at this, I'm going to let my ak equals to this is please look here. Look here. We are going to do something funny here. Please look here. Now I'm going to, remember the previous example has been already splinted into even and odd. Also, we are supposed to split this into even and odd. What does it mean? It is going to remain in negative 1 to power n. Remember, by mere checking from here, it is going to produce, when I substitute, it's going to produce negative 1, 1, negative 1, 1, and other things. So the lowest are going to be produced by odd when you try to check. This is when n is odd. Now, remember when you apply the other knowledge, that negative 1 now, power n plus 1, if this is n is odd, then here n is even. Please, what I've done is to increase n by 1 so that I can make it even now. Meaning that if I pick here any even number like a 2, when I add here 2 plus 1, I will get 3. When I substitute, I will get back the same answers that I've been getting there. Then that is our AK. So we are supposed to look at BK also. This is the same as what? Please look here. Now remember, when we say that it is odd here, we picked out negatives. Now we are picking the positives. What does it mean? But it is better you take this arrangement odd even, meaning that here I want even, odd. If I want even, then I will take negative 1 to power n. And this is n is even. When I want it odd, I will say negative 1 to power n plus 1. I want it n odd. And in this, some books, what they will do, if it is a fixed number, if it is a fixed value, they will just say, okay, take an equals to this is, because we have said, or we have seen here that whenever you put a negative, an odd number, you get a negative 1. So they will just tell you, okay, this is a negative 1, n is odd. And they will tell you negative 1 to power n plus 1, n is even. You find that they will be just fixing a value, but here we are not going to fix because of some other complicated examples which may come on our table. So I'm not using this where they just substitute and they put for year 1 already. No, that one I will not go with it for today for some other practical reasons. Now, let's go to this one here, AK. You'll find that this is the AK equals to, or we can say limit I think let's just move on at once. I think so. So for limit inferior, let AK equals, this is the infimum of the K greater or equal to N of this is Xn. This is equal to what? This is inferior, K greater or equal to N. When I put this, you'll find when we go on substituting odd numbers. Remember here we have said the reason why we are taking odd and even is 1. Remember here, odd we are referring to 1, 3, this is 5, this is 7, and others. Here even we are referring to 2, this is 4, this is 6, and others. Now when you combine this and this, you are going to get the whole of n. Now, when you put, we will check here that when you put here a 1, you will get negative 1. When you put here a 2, you will get negative 1. When you put here a 3, you get negative 1. When you put here a 4, you will get negative 1. Here, when you put a 4, it implies that this and this, that is 5. Then negative 1 to power 5 will to be negative. That's why I'm saying they will be negatives. So here, after formulating A and formulating B, you are free to take everything you want. But what is important is to know, am I substituting odd or am I substituting even? So that is where the difference is. Now, let's move on here. You will find that in this case, you are going to see that when I substitute, I will get negative 1, negative 1, negative 1, negative 1, and others. And then here I will get finally negative 1. Therefore, when you try to check, therefore, limit inferior, as this is n goes to infinity, of this is the sequence, what do I get? I'll find myself getting this is the limit, as n goes to infinity, of this is the AK. This is the limit as n goes to infinity of this is negative 1. And then finally I will have my negative 1 there. So limit inferior as n goes to infinity is negative 1 here. Then when I go for limit sup, what are we having? We are going to say from BK, which is the same as limit. This is sup as K greater or equal to N of this is Xn. But remember we know Xn, meaning that in this case, this is the sup of this is the, when you substitute here, odd or even, you find that you are every time getting 1. Because when you put any odd here, meaning that when you put, say, a 1 plus 1 you get 2. Negative 1 to the power 2, it will be 1. Here, when you go n is equal to 2, it implies that n negative 1 to the power 2, you get 2. So you shall get a 1 in every case. So this is 1, this is 1, this is 1, up to others. So this is K greater or equal to N. And as N goes to infinity, you find that you get back a 1. It implies that it will not change. This is positive 1. It is positive 1. So if you have got positive 1, we can say, therefore, limit sup of the sequence Xn as n goes to infinity. We shall find ourselves having this is the limit as n goes to infinity of this is bk, and then this one here will equal to limit as n goes to infinity of 1, and finally you're going to find yourself with a positive 1. So limit sup, when you try to check here, when you try to check limit inferior, we have got -1. Limit superior, we have got a 1. Now, we have not seen a situation where limit superior is equal to limit inferior, meaning that along with these two examples, the two are divergent. Now, sometimes when I try to take you back to number 1, look what number 1, the way it was, because there's something I want you to know there. Number 1, there's something small I want you to know. Number 1, before even I try to move on. Now, when you look at number 1 can be totally sketched, and then you see. Also, number 2 can be totally sketched, and you see. Before we go to number 3. Now, let me use this pen here. Number 1, when you check the even numbers, remember this line is for n. N implies that I have a 1, I have a 2, I have a 3, I have a 4, I have a 5, and others. Now, this is our xn, the ordinary sequence. I want to sketch number 1 because it is the easiest or the simpler you can see when if you're a beginner. Now, you see, this one is still continuing, don't forget. Now, you see, this is the sequence is having 2 parts. It's having this upper part and having this lower part. Remember, here they have said this is odd, this is even, meaning that if you're having even, we know what to move on with. I'm first sketching even. Even when you plot, even you start with the first even 2. 2, when you substitute a 2, you get a 2 here. So you find that you have a point there. When you put a 4, you have 4, so you get a 4 there. When you put a 6, you find that you have a 6, so you have a 6 there, and the others as it continues. Meaning that if you are to join, you have this. You have a sequence to this side. Now, when I go back to the odd ones, when I go back to pick up the odd ones, it implies that I'll start with the 1, meaning that the first one will be 1. Then when I put a 3, it will be 1/3, so it will be close to 1. When I put a 5, it will be 1/5, so it will be so close to 0. So when I join, I will get something fun like this. And it will continue, but it will never meet the x-axis. This is my n, this is my 1/n. These are sequences. You will see that because this one tends to 0, as n goes to infinity, and also this one tends to infinity, actually positive infinity to be specific, as n goes to infinity. What does it mean? It implies that you will see that this one will continuously go to infinity and this one will continuously go to 0. That's why we have the other 2 answers, that we're having a 0 and infinity. If you are used to use a sketch, but a sketch automatically it cannot give a clear explanation over this. That's why we are not going to use it to give the answers. But you can sketch them still. Meaning that what I was telling that you can sketch and get the answers, but they are not so conclusive. You cannot just try to conclude with them. Meaning that they are not so easy. Now you see number 3. Number 3, I want you to look at number 3. I think I will skip number 4 because there are many examples. Number 3, let's try to look at number 3. Our xn equals to this is 1 plus, this is -1 to power n. This is our sequence here. We are going to still divide it into 2. We are going to divide it into even and odd. Let, in this case, our AK be equivalent to, this is the, now, remember I've said it's better you go with the odd, even, but what necessarily is, our AK most cases to give you the smallest. So the smallest, you see when I put odd values here, I will be subtracting from 1, so it will be reduction. But when I put even, meaning that when I put like a 2, it will be addition, meaning that odd, they will give me the smaller ones. So I have 1 plus negative 1 to power n, n is odd. N is odd. Now, remember, this is odd. So we want to go to even of this, meaning that we are going to say 1 plus, this is a negative 1 to power n plus 1. This is n. N is even. So this is our AK. You are free to simplify this to have something funny, 1 minus 1. Of just 0, but I'm not going to simplify. Let's leave it. Let's leave it because I want it big like this. So BK, also BK will be the same as what? Now remember, I've said you start. It's better you have the same arrangement, odd even. Then what does it mean? I'm going to have here something funny, which is I start with the lower one because I'm intending to capture the even. This is 1 plus negative 1 to power n. N must be even now. Then I have 1 plus the alternative of this 1 plus this to power n plus 1. This is n is odd. You'll see that when you try to substitute, you have the same values. This is n, not 0. This is n. It looks funny. It is n, please. Now, we are going to look for limit superior and limit inferior. Then we are going to have this. So for limit inferior, using AK equals, this is the infimum of this is the k greater or equal to n of the sequence n xn. This will equal to this will equal to inferior as n goes to this of this is the. When you substitute, what do you get? What are the values you are getting? When I substitute in any odd, when I put a 1 there, I'll get 0. When I put 3 there, I'll get 0. When I put a 5 there, I'll get 0, and all others. So taking the infimum, it will be a 0. This implies that limit inferior as n goes to infinity of this is the sequence will equal, this is the limit as n goes to infinity of this is 0, and finally I will have myself a 0. Then finally I have BK for limit superior. I can say using BK equals to this is the infimum. Sorry, this is the supreme of nk greater or equal to n of xn. And then this one here will be sup. This is the k greater or equal to n of this is when I substitute properly. When I go with even here, this is my bn. I want to go with the even, meaning that when I go with the first one, which is a 2, I will get here 2. So meaning that I will put it 2, then it will square, then I will get it as a 2. This is a 2. When I put a 4, it will be a 2. When I put other things, it will be a 2. So I will continue as having a 2. So this is a 2 here, the supremum. This indicates indicates to me that if I want to get the limit, this is n goes to infinity of this is in soup of xn, which is the limit superior, equals to the limit as n goes to infinity of 2, and finally I will have a 2 in my pocket. I know you know how to move from here to get a 2 there. Then that is how you do that number. That's how you do that number. Then let's move to number 4, then 5, and then we finish for today. Number 4. Hope I still know the what. Let's move on to number what? Number 4. Where is the number 4 now? Yes, it is here. So this is the number 4 here. Let's see what happens, because there is something which I want you to know from there. So this is our xn equals to n into 1 plus negative 1 to power n. And we are going to let have a k equals to what? This is n into 1 plus negative 1 to power n. I want n odd. Then this is n plus 1 into into 1 plus negative 1 to power n plus 1, n even. Then also you are going to have bk. We shall have it as this is n. Sorry, I'm starting with the lower part. This is n into 1 plus negative 1 to power n. This is n even. Then the next one is n plus 1 into 1 plus negative 1 to power n plus 1, n odd. So today's work, it will be simple. I think you have to receive it immediately after these examples. So when you try to look at properly this expression, this is a 1, this is a 1. I'm going to take for limit inferior, ak must equal to what? To the limit. So infimum, k greater or equal to n of xn. This is equal to inferior, k greater or equal to n of this is when I substitute, what do I get? Please look here, look here, look here. When I put n is equal to 1 here, what do I get? I get a 0. When I put n is equal to 3, I think still I will get a 0. I'll get a 0 like that. So here I'll get a 0. Therefore, limit as n goes to infinity of this is inferior of xn, it will equal to this is the limit as n goes to 0 of ak, which is our ak is 0, which is 0. The difference is going to be on finding limit soup. So for limit soup, bk equals this is the soup, k greater or equal to n of xk. This is the soup. K greater or equal to n of this is in. When I put here, a what? A 2, I'll get 2. When I put here 2, I will get 2 here. So this will be a 2. When I put here a 4, what do I get? This is a 4. When I put here a 6, what do I get? I'll get a 6 here. Please, hope you know how I've substituted. I put here even. Even I have a 2, I have a 4, I have 8. When I put here 8, this is 8. Then this is the, this value is the, I think I'm not right. No, I'm not right. When I put here a 2, I'll find myself with a 2 into 2, which is 4.
Then 8
yeah,
and 12.
You are right. This is a 4, this is 8, this is 12, and others. Now, you will see that when I substitute as many n's as possible, I'll find myself with the positive infinity. So limit soup as n goes to infinity of this is the sequence xn will equal to limit as n goes to infinity of infinity, automatically we shall get infinity. So that is how it comes about. Now number 5 will capture. Number 5 is going to capture the last bit of the. Number 5 is going to capture the last bit of what? Of the other last property we saw, which is nice. Number 5, we are having xn equals to, this is 1 plus negative 1 to power n of 1 over n. Now, this is something good. Our ak equals to what? This is 1 plus negative 1 to power n, 1 over n, n is odd. Now, please look here. Look here. You will see that any value you will put, when you pick odd number, any value you put it to be -1. So sometimes what people do, some friends of yours, when you go around to read many things, you'll find that they will just write 1 minus 1 over n. Because every time they are going to substitute here, you get a negative when you pick an odd number. So they will just write 1 minus 1 over n. But because this is unexpressed, this is not a simplified expression, so we can move with this so that you pick up how it is coming about. N plus 1, 1 over n plus 1. This is n even. Please, to write any even and any odd is to exhaust every value on n. That's why we are writing them. So bk, we have this is a 1 plus negative 1 power n, 1 over n, n is even. Then this is 1 plus negative 1 power n plus 1, 1 over n plus 1, n odd. So, when you try to look at this properly, let's move on with the solutions. For limit inferior, what are we having? you will see that we are going to say using this is AK equals to this is inferior of K greater or equal to N of XN, and this will be equaling to inferior K greater or equal to N of this is yes, what are we having? When we substitute properly any odd, what do we get? The first one will be 1 minus 1. This is 0. I think this is 0, right? This is 0. Please help me substitute. This is 0. When I put 1 minus 1 over 2, 1 minus 1 over 3. Please, Ashaba, what are the answers here? I'm substituting in NK.
It's 0 all through. 0 all through.
0.0?
0, 0, 0, 0.
0.667. Another one 0. What?
Excuse me, sir. Excuse me, sir. When you substitute for any odd number, it gives you 0 because there is already 1 minus 0. I thought.
Oh, no. This is 1 over N.
Yeah,
There is N here.
Yeah.
Meaning that it will be like 1 minus, because it will be even, 1 minus 1 over N. So when I put 1, I will get a 0. When I put 3, I will get something funny, which is 2 over 3. When I put 5, I will get something 4 over what? Over 3, over 5, like that. So it cannot, yeah. My dear. What is here? This is okay, right? What is this? It is okay?
The next is 0.8.
Yes.
0.8.
0.8.
So you will substitute to find that this thing here, when you put as many terms as possible, it will be close to 1. You substitute to find that you will reach a point when you are having 0.9999 something, so which is close to 1 as you substitute many. So you will see that during your free time. Then you will see that therefore our limit inferior as n goes to infinity of this is xn. We shall have limit as n goes to infinity of this is ak. This will be the same as the limit as n goes to infinity of this. Please, can you mute your mics? Of this is 1. We shall finally get a 1. So for limit sup or limit superior, what are we going to have here? We are going to have something funny here. We are going to have a bk equals to the limit, equals to sup of k greater or equal to n of this is in xn. This is the sup k greater or equal to n of this is in bk. Please, can you try to check bk? What we have? When I put even here, this is the one. When I put even here,
I have a third. 1.
The first one will be
a third. I have a third.
Yeah. You are lying. You are lying. When I put
So the first one is
it will be
0.5.
first one is
No. Things, you are lying. When I
First
put a 1,
3 over 2.
which is 1.5,
Yeah,
when I put
yeah,
another
yeah.
one, it's 1.25. Please, you substitute your things. You substitute many, yes, but you'll find that it will be coming back at 1. It will be so close to 1.0000 something there, like 1. Meaning that it will be coming back to 1 as you substitute as many as you can. So, therefore, limit as any
Excuse me, sir.
so, yes.
Excuse me, sir. I haven't understood that part, because I'm saying 1.5 is bigger.
1.5 is big, eh?
Why are you saying you will take 1?
Ashab,
Yeah, 1.5 is big. If you're saying you
please look.
substitute.
Look here. We are looking at as n goes to positive infinity. You get it, eh? We are looking at where these things are supposed to converge from, where many are going to be giving us the same answer. Not the biggest. So you should take a note of that. Take a point which is giving us many. You remember the other, actually I thought you understood from the other side. Because I used 1 over n, but I was substituting, you see you have, when you substitute here, you have a 1 here, 1.5, 0.5 there, you come like this, but I took a 0 because many were giving me answers as n goes to infinity. Many were giving me answers here. But I didn't take a 1. So what I can tell you is that, please, who? What I may tell you that you take, okay, you can say you cannot take the convergent value, not the biggest value of the sequence. So what we do, it is like this. This expression here, because everywhere we are taking limits as n goes to infinity, it implies that we are looking at a situation where the same answer has been given many times as we substitute for n goes into infinity. That is the interpretation there. But we don't take the biggest. You are right actually to ask here, because it was to cost you. We are not interested in the biggest. This expression here, n greater or equal to n, implies you look for the most dominant answer, most common answer. And when I look for the most common answer, I will find it when I substitute many times, and it will be giving me 1 point something, but these somethings will be close to 0. Actually, I will reach to a point where I have only 1. Because remember, I can take a situation where I have 1 over 1,000 or some good values. There is someone taking us process by process. I don't know if she is aware. The good thing, 12 of them are putting on a mask, so it will be good for them. So you see, this one here, it will take us some good work. Then you remember you subtract or you add it on a 1, meaning that this is 1, because remember our Bn is like this. Meaning that this one at any time it is going to be positive. So it is 1 plus this one can be so small, close to a 0. Meaning that it can be 1 plus 1 over 1, maybe 100,000 or 100 millions. you see that this one will turn it to something 1.00000. Actually, there are 7 zeros. You will see that this one is, this answer 1.00, many zeros, it will be dominant. And being dominant, it implies that as n goes to infinity, it is that answer. So you are right to ask. So let's move on. Hope you know why I'm taking this positive one here. Please, I'm taking the most converging answer, the answer which appears to converge to. Because this is a sequence. However much we are taking subsequences, but this is also a sequence. So you look where it converges most. And it is a 1 here in this case. Please, you keep substituting, you'll see that you are going close to a 1. You are going close to a 1. That is the thing. So limit as n goes to infinity of this is soup of this is the sequence xn equals to limit as n goes to infinity. I think you can see we are taking a limit as n goes to infinity of bn, meaning that we are interested in that value where you have seen it appearing many times as you substitute any values. And then finally we are going to find ourselves that you have already seen a 1. So now I'm going to make a conclusion on number 5. Look here, please. You see that limit info as n goes to infinity, limit infimum. You have seen that limit infimum of xn has been equals to limit supremum. It implies that for this case, xn must converge to what? To 1. That is the interpretation of the last theorem. Even in the handout, I think I put it there. Check in the handout, it is the last theorem. And when you look at the other notes you have written, which were out of the handout, it was there as the last concept you wrote. So that is the thing. So you read through those important standard limits under 3.6, then they will help you much on your understandings, but not now. Do you know